Good morning.
Good morning, sir.
Good morning, sir.
Good morning. So yesterday we have done what is charge, different type of charge, and how we can charge or different ways to charge the object, then quantization of the charge, conservation of the charge, law of conservation of charge. So these all points we have discussed. Today we are going to start Coulomb's law. So our syllabus starts from here. Quantization of charge is there. After that, Coulomb's law is also there. So, Coulomb's law. Coulomb's law says the force of attraction or repulsion. So in case of charge, what happens? Like charge repel each other, whereas unlike charge attract each other. In case of gravitational force, only there is force of attraction, no repulsion. Only attraction is there. Whereas in case of electrostatic force, the force between the charge, there is attraction as well as repulsion. In case of magnet also, attraction and repulsion. So this electrostatic force, which may be positive or which may be negative, so this force of attraction or repulsion between any two charges is directly proportional to product of these two charges. So this F is directly proportional to product of these two charges and inversely proportional to the square of distance between these two charges. So this F is inversely proportional to square of the distance between these two charges. So if we combine these two, what we will get? This F will be directly proportional to Q1, Q2 over R square. Now, when we remove this proportion relation, we have to give a constant. So this F is K Q1, Q2 over R square. So this K we call proportionality constant. This value of K, so this K is 1 in ESU, that we call electrostatic unit. Or in CGS unit. So sometimes we use this to solve the problem, numerical problem. In this case, what will be in ESU, Q1 and Q2 will be, or Q1 and Q2 are in stat Coulomb. Or in centimeter. F is in time. So if we are using this one, value of charge in stat Coulomb or in centimeter, then F will come in dyne. Or just reverse. If force we are taking in dyne or in centimeter, then whatever Q1 and Q2 will come, that will be in stat Coulomb. So this we call electrostatic unit or CGS unit. In electrostatic unit, this Q will be in stat Coulomb. Afterwards, we will say what is the relation, or just we can, or we will derive it, that will be better. Relation between Coulomb and stat Coulomb. Afterwards, we will derive. Now, in SI unit, this was the old concept. Earlier, we used to do this one this way, electrostatic unit. But nowadays, this is not used. Nowadays, we are using SI unit. And in SI unit, the value of K so when as this one, nowadays what we are doing, when there is a spherical symmetry, means whenever we are placing the charge here, suppose it will attract this charge also, which is right side, which is left side, or here, or up or down. So this we call spherical symmetry, that is in 3 dimensions. If anyone has got circular symmetry, like the relation is valid only in a circle, then this constant is associated with one more constant, that is 2 pi. In case of volume symmetric, that is when it is 3-dimensional figure, then we are giving a constant which must have the term 4 pi. So this K is, we are saying 1 by 4 pi, another term is here epsilon. So this epsilon will depend on the nature of medium. Because this electrostatic force, what will be the force acting between the two charges, that will vary from medium to medium. It is not like gravitational force. In case of gravitational force, what is happening? It depends only on the product of the mass of the two objects and inversely proportional to the square of the distance. And there, what constant we are giving? And that state constant was G m1 m2 over r square. And this G is what? We call it universal gravitational constant. So the value of G does not depend on the medium. That means gravitational force, if the two stones are kept in air or two stones are kept in water or any other medium, the force of attraction will be same. It will not change. But if the two charged particles are placed in air or it is in some other medium, then force will change. So as this force is depending on the medium, That's why this term is coming. As it is having volume symmetric, so 4 pi is also coming. That's why the constant we are giving 1 by 4 pi epsilon. And epsilon we call permittivity of medium. So for air or for vacuum, this epsilon will be equal to epsilon naught V. 0 we are writing, that is, has got the special value, special meaning. In expression, if it is epsilon naught is written, that means we are considering the medium vacuum. Vacuum and air almost same, it will come. So that's why air or vacuum, this epsilon will be equal to this much, and this K will be equal to 1 by 4 pi epsilon naught. And this will have a particular value, and this is equal to 9 into 10 to the power 9 in SI unit. As we are taking in SI unit only. What will be the unit that will come afterwards? That we will discuss. What is the unit? So this is the value.
Sir,
Yes.
sir, how the 4 pi is coming, sir, plus
Which one?
the K equals to 1 by 4 pi. That one, sir, how 4 pi is coming?
Yeah, so 4 pi, why we have selected? Because this force will have a volume symmetry, means it will, if any charge particle we are placing here, it will attract or repel the other charge particle which are present anywhere in the space. So sometimes we call space symmetry or volume symmetry, that is, it has got the 3-dimensional. Now, like volume of a sphere, what is coming? Volume of the sphere 4 by 3 pi r cube. So 4 pi is there.
4 by 3, sir.
4 by 3 pi. So 4 pi will be always there. Any volume, anything, whatever you will consider, 4 pi will come in that case. In case of circle, if it is valid in only in one plane, area of circle or circumference by pi square, so pi is only there. So in case of if anything which is related to plane, the force is experienced only in the plane, no up, no down, nothing, only in plane. Then in that case, 2 pi will come. Here, 4 pi will come.
Sir, if one charge is kept in water and one charge is kept in air, then sir then permittivity of medium will be E naught or E epsilon or epsilon.
It will depend on whatever medium, how much it is or how much air.
One part,
some part will be in the air, some part will be in the water.
Yes, sir.
So we will have to find the equivalent permittivity of that medium.
Oh, okay.
If it is just immersed in water and this one, so maximum is only air, so we can consider air only.
Oh.
So medium, different medium are present, then equivalent we have to find. What is the equivalent permittivity of that medium? So if we are using this one, then what will be? So this F will become 1 by 4 pi epsilon Q1 Q2 over R square. Now this epsilon is a new term. So we will find the unit and dimension of this. So this epsilon will be how much? Q1 Q2 over 4 pi F R square. No, F will come down. So what is SI unit? This is Coulomb square, Newton meter square. Whereas if we are writing K, then what is the unit of K? K Q1 Q2 over R square. Then SI unit of K, this constant will be what?
Sir, Newton meter square by Coulomb square
Newton meter square
per Coulomb square.
per Coulomb square. So reverse of this epsilon. Now what will be the dimension? Sometimes it is asked dimension of epsilon or epsilon naught, because they will have same unit, SI unit of epsilon or epsilon naught, same thing. So this is of medium and this is particularly of air or vacuum. Unit will be same. So this charge, how we say? What is the charge? Current is
Current into time, sir.
current into time. So Q1 into Q2, what will become?
Ampere into
Ampere, that A or I, whatever is symbol you are using, A square T square.
there, sir. By
No dimension,
hmm.
force mLT minus 2 L square. So how much become? M to the power minus 1 L to the power minus 3. Correct? M minus 1 L cube T4 A square. Yeah, correct only. Now for air or for vacuum, what will be? this K, which is equal to 1 by 4 pi epsilon naught, that will become 9 into 10 to the power 9. And what will the unit? So this one will become Newton meter square per Coulomb square, or Newton meter square Coulomb minus 2. Now, what will be the value of epsilon naught? So it will become 1 over 36 pi 10 to the power minus 9. So when we solve this, you will get 8.5. What is it? Anyone having book?
Sir, 8.841 something coming. 41.
4.1
Yes, sir, 4194 into 10 to the power minus 12.
minus 12. Coulomb square over Newton meter square. Okay. So this is the value of epsilon naught. So value of K for vacuum will become this much, whereas sometimes we use epsilon naught, then this value we have to use. Now suppose we are doing relation between Coulomb and discharge Coulomb. No, first we should define 1 Coulomb. After that we will do this one. First definition of 1 Coulomb we will do. How we define 1 Coulomb? So as we know, in case of vacuum or air, suppose we are writing this F naught. This is how much? 9 into 10 to the power 9 Q1 Q2 over R square. If placed in, if charges are placed in air or in vacuum. So what will be, how we define this one? If suppose this R is, if Q1 equal to Q2 is 1 Coulomb and R is 1 meter, then what is that?
Into 10 to the power 9 only.
So 9 into 10 to the power 9 Newton. So we are using this property to define 1 coulomb. So how we define 1 coulomb? If two identical charges when placed at a distance of 1 meter in vacuum or in air, experiences a repulsive force. As the charges are identical, that means what? If this is positive, that will be also positive. That is meaning of identical charge. Magnitude is same and nature is also same. Then only we say two charges are identical. So experiences a repulsive force of 9 into 10 to the power 9 Newton. Then the two charges are said to be of 1 coulomb. So if two identical charges when placed at a distance of 1 meter in vacuum or in air experiences a repulsive force of 9 into 10 to the power 9 Newton, then the two charges are said to be of 1 coulomb. If placed in another medium, it will not experience the same force. Or now this one, relation between Coulomb and start Coulomb. So suppose 1 coulomb is x stat Coulomb. Sometime in competitive exam, when you will solve the problem, this one will become easier. So that's why. Otherwise, in ISC, this is not required. Because nowadays, only we use this one. Just when you are given the objective time answer, then sometimes we feel, okay, when you will choose this one, CGS unit, the calculation is very easy. So then what will be, suppose we are using the same thing here. So this F naught, which is equal to 9 into 10 to the power 9 Newton, will become 9 into 10 to the power 14 times. When R we are taking 1 meter, that means 100 centimeter. And Q1, Q2, which is 1 coulomb into 1 coulomb will be how much? X square stat coulomb. In place of Q1, 1 coulomb, we are writing x stat coulomb. Here, x stat coulomb. Here, 1 meter. Then what will be the force? In place of this much Newton, otherwise, if you have taken this one, this is the force. Now, force will become this much dyne. So, what will we get? 9 into 10 to the power 14 kg here 1 in 6 unit. X square over 1. No, 1 meter means 10 to the 4. So, what is the value of this x?
The 10 to the power 4, how coming, sir?
This is meter square. R is 1 meter.
Yes, 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 sir.
R square.
Yes, sir.
Got? So, this x is how much? 3 into 10 to the power 9. So, what does it mean? This 1 coulomb will be 3 into 10 to the power 9 stat. The other term is relative permittivity. So whatever this we are discussing, similar term will come in case of magnet also. That is, two pole strength will be given, the force of attraction or repulsion, same thing. Only the constant will change. Here constant is 1 by 4 pi epsilon naught, and there constant will come mu naught over 4 pi. Where mu naught we call permeability. Here it is permittivity, and in magnet chapter it will come permeability. The derivations will be, all the terms will be similar. Okay. So this now relative permittivity of the medium. Relative permittivity or dielectric constant. Symbol we give epsilon r, or sometimes we say K, dielectric constant K.
So that is also okay. This is also okay.
Yeah, that K over now. Now it will not be coming again.
Okay.
Now this K will, so with 4 pi, if something is coming,
Yes.
then that is in place of epsilon it will come. Now, when two charges are placed in air, or vacuum at distance r, Then what will be this F naught we can write 1 by 4 pi epsilon naught Q1 Q2 over R square. When the same two charges are placed at same distance, same two charges Q1 and Q2 are placed at same distance or in some other medium. Then what will be the force experienced by the two charges in that medium? F naught we say force experienced when placed in air or vacuum. Fm we are saying the force experienced when placed in that particular medium. So what will come? 1 by 4 pi epsilon Q1 Q2 over R square. Now, if we divide these two, what we are getting? So this divided by this
Epsilon by epsilon naught.
come
Epsilon by
7 over epsilon naught. Rest all is same. So this only we call say. So this ratio we call epsilon R or K, dielectric constant. So how we define this epsilon R? So it is a ratio of force experienced or force of attraction or repulsion between two charges when placed in vacuum and in other medium at same distance. So charge is same, distance is same. Only medium we are changing. So epsilon R or K is the ratio of force experience or force acting between two charges when placed in air or vacuum epsilon R. this relative permittivity will be of any medium. So you can write like this. So relative permittivity of any medium, because it will change with medium, epsilon r or k, is the ratio of force experienced or acting between two charges when placed in air and in that medium at same distance. So whatever distance will be in vacuum or air, in that particular medium will be also at the same distance we have to place. So as it is ratio of same physical quantity, that means what will be?
No unit.
Have no unit. So this epsilon will be epsilon naught, epsilon r. No, this epsilon over epsilon naught is epsilon r. So this epsilon will be epsilon naught, epsilon r. So value of epsilon naught is fixed. So only this epsilon r will be given. That's why this term, another term is defined here. Epsilon will not be given. What will be only the dielectric constant of that particular medium will be given. For example, when we are placed in paper, it may be the dielectric constant is 5. Or in glass, dielectric constant is this much. So for any other medium, what will be this dielectric constant will be given. Epsilon naught we are knowing, epsilon r will be given, and that will be in the form of number only. It is minimum for vacuum. So this epsilon r or k equal to 1 for air. And this epsilon r is infinity for matter. It is good conductor. So this epsilon r is not less than 1. This is the minimum value and this is the maximum value. So for any other medium, it will be within this value only. Now Coulomb's law in vector form. And it is force experienced. So naturally what will be? It will have direction also. So we have to represent the magnitude as well as direction both. Now suppose we are saying both the charges are positive. Then what will be? This charge will be repelled by this, and this charge also will experience force of repulsion. So what will be the direction of force experienced by this charge? Right or left?
Right, sir.
Right. So the force experienced by this charge will be in this direction. So we are writing it F21. That is force experienced by second charge due to first charge. Now what will be the force experienced by this one? Read left or right?
Right.
Left.
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 Yeah.
Left.
It will be also in the left direction.
F12.
This is force experienced by first due to second.
So that is left. Sir.
Okay. So suppose this is 5 Coulomb and this is 10 Coulomb. Which one is more? F12 or F21?
F12, sir.
F12.
Yeah, F12 is great.
Anyone? Any other? F21?
F12 is great, sir.
Sir, what is the value of Q1, sir?
Q1 is 5 Coulomb plus 5 Coulomb and Q2 is plus 10 Coulomb. Would Abhinav is also visible?
Every day I'm visible, sir.
Where were you?
Every day
Not
I
every-
attend.
not-
sir. Each
Where
day
is
I
your
attend.
friend Mohit? Where is your friend Mohit?
Sir, Mohit is playing cricket, sir.
Huh?
He is playing cricket, sir.
He's preparing cricket.
Yes,
Yes.
sir.
He's enjoying Corona time.
After Corona.
Yeah.
So what will be here? So F21 is this side, F12 is this side. So which one is more?
F12.
F12. Anyone saying F21?
Sir, why?
Why I am not saying? I have not given the answer. I have not given the answer.
Oh.
Anyone F21? No. Anyone saying both are equal?
It can't be.
No one.
Yes,
Both
sir.
are equal.
Both are equal, sir.
Magnitude of this F21 and F12 are equal. And how much? 1 by 4
Q1,
pi
Q2,
epsilon
yes.
naught,
Q1, Q2 by R.
square. So whatever the value of Q1, Q2 may be, the magnitude of these two forces will be same. Magnitude are not different. Whatever force Earth is attracting on Apple, by the same force, Apple is also attracting Earth. No, both are experiencing force due to each other, and that force will be same. So here also, force experienced by Q1 and force experienced by Q2 both are magnitude will be equal, but they are opposite in direction. If one is positive, other is negative, what will be? Both will experience force of attraction. So this force will be this direction, this force will be that direction. So they are experiencing equal and opposite force. Okay. So magnitude will be same. Now only direction, how will you represent? So if this the distance is r, then we are saying this F21 will be 1 by 4 pi epsilon Q1 Q2 over R square. And how to represent direction? Magnitude is this much, then vector is always represented by magnitude and then with unit vector. When we have represented magnitude separately, we have to give a unit vector. Now here unit vector will be R12. Suppose like this. Then you have to define, because this is not a standard. IJK is not there, so it is not a standard unit vector. So we have to define where R12 is unit vector along the line joining first and second charge. Okay. First charge means Q1 and second charge means Q2. So it is in this line. In some book you may find this F21 is 1 by 4 pi epsilon naught Q1 Q2 over R square and R21 like this. Then there, what is the concept? This R21 is unit vector along the position vector of Q2 with respect to Q1. That is the concept there.
So once more, can you explain, sir, from here?
So if we are finding like this here, unit vector R21 here, then their concept is this one. Unit vector along the position vector of Q2. So when we are represent position vector of Q2 with respect to Q1, what will be? This line. So in some book you will find this one, some book you will find this one. The concept is here will be the position vector and here will be the unit vector along the line joining these two charges. Now suppose we want to write it 1 by 4 pi epsilon naught Q1 Q2 over. We want this R12 vector, not unit vector. Then what will be?
So what?
In place of unit vector, we can write here vector. So unit vector is what? The vector itself by its magnitude.
Magnitude.
Yes, sir.
What will be coming here? RQ. So R12 vector is, means this one unit vector will be the vector divided by its magnitude, and magnitude is what? R only. Yes, any confusion? No. Similarly, what will be this F12, if you are representing, then what will write? So here will become 2, 1. So sometime in one mass question, you may not find this option. In place of that, this will be given. So you have to use both the concept. Both are so either unit vector or the vector itself will be written. So if vector will be there, then here will be r cube. If unit vector is there, then here will be r square. Over. Similarly, here if it is F12, here will be also 1, 2, then R12 will be the unit vector along the position vector of Q1 with respect to Q2. Clear up? So if we want to compare this electrostatic and gravitational force, generally in objective type question it is asked, you are given that two electrons are placed at a distance, whatever the distance may be, at distance r. You will be asked to find the ratio of this electrostatic force of repulsion and gravitational force. So in this case, electrostatic force will be how much? 1 by 4 pi epsilon naught Q1 Q2 over r square. So how much will be 9 into 10 to the power 9 charge of electron. Q1 and Q2 both are E. And 1.6 into 10 to the power minus 19 by r square. Okay. Now what is the gravitational force? What is gravitational constant? .67 into 10 to the power. What was that?
Minus 11.
Minus 11. Mass of electron.
9.1 into 10 to the power minus 31 kg.
Okay, so 9 into 10 to the power minus
1 kg.
31. It will become 9 into 10 to the power minus 31 whole square over r square. So if we find this ratio, so when you will solve, you will get of the order of 10 to the power 41, I think. 9 times. It will be 10 here, suppose. That means 72. 72 plus minus 29. 2 minus 29, yeah, 41. That means this electrostatic force is 10 to the power 41 times the gravitational force. This is in case of two electrons. It will be different for different case, but frequently one mass question, this one in competitive exam will be asked. So no need to do the calculation. This result will be sufficient. So this electrostatic force between the two electrons is of the order of 10 to the power 41 times. So we say this electrostatic force is much more in comparison to gravitational force. So electrostatic force will be very high in comparison to gravitational force. In comparison to magnetic force also it is much more. So if we compare, then what will be? This one will be the highest force which in nature it is present. More than this, nuclear force is there, which is not present in nature, it is within the nucleus, and that also exists for short range only. So this is how to compare. So sometimes one mass question solution also will be given in the form of, will solve by using the ratio method. So for example, suppose you are given when two charges or two equal charges, you can say equal charges are placed at a distance r, the force of repulsion in F. What will be possibly find first maybe the force between them when distance is increased by 3 times. So here nothing is mentioned about medium. So we'll take medium same. If something specially mentioned about medium, then only we'll change the medium. Here nothing is mentioned. So medium will be same. So in this case, what will be? This F is what? Suppose this K 1
By
over
3.
R square. Okay. And this F dash will be what? K.
By
Only
9
distance will increase 3 times. So Q is same. Now distance will become
9
9 R square. So what is the result? This F dash will become 1 by 9th of F.
Hmm.
Now second one. What will come? So again, F will be same. K Q square over R square. And F dash will be what? Charge and their separation both are increased by 20%. So what will come?
Q plus
K
0.20.
1.2 Q square over 1.2 R.
Square.
So it is 1.2 K Q square over R square. That means this F dash will become 1.2 times F. Now third one you are asked percentage change in F. Here it was new force only. Third one you are asked what is the percentage change in force F.
Sir, their verbs are that their charges and the air separation is yes sir, it will cancel no sir.
We cancel. So it will be equal.
Yes sir.
Yes, sir, equal.
So that will no effect.
Yes, sir.
So percentage change means what? Delta F over F into 100. Delta F means what? F dash minus F over F. So again we find this F dash by F. So here charges are increased by 40% and distance is reduced to 60%. So what will be F and what will be F dash? So this F same KQ square over R square. Now F dash K. If this change is given 1% or 2%, like percentage error, you can solve. But when there is large change, then we can't use the formula of percentage error. So in this case, what will be? Charges are increased by 40%. So what will become? 1.4 Q whole square.
Yes, sir. 0.4
And distance,
decreased by 60%.
how much?
Reduced 0.4 R whole square, I guess.
0.4 R.
Yes, yes.
Yes, yes. Any other?
Reduced now, sir. Then what we will do?
Huh?
Sir, reduced it is written. Now, then what we will do?
Reduce it is given, but when you will read properly, then only you will understand, no?
0.6 are no, sir.
Huh?
6 only. Just 60% will take, sir. Not reduce it.
Reduce to 60%, not reduces by 60%.
Only 2 till
So
6.
it will be simply 0.6.
Yes, sir.
60%. Oh.
So that's why it is said, read the question properly. Now this F dash over F. So how will it become? 7/3 whole square, no? Forty-nine by 9.
Yes, sir.
So this F dash by F. 49 by 9.
ठीक है, तो आज से होगा.
So 40 by 9, this much percent. %444. Or 0.4 also you can have, no problem. So the force will increase more than 4 times.
Sir,
Hmm.
so how the 49 by 9 is coming?
This is here. So when you remove the decimal, what will happen? This is 3, this is 7. The square of this is whole square. No, suppose like this, whole square only.
Yes, yes.
Now another one, suppose you are given when two charges placed in a medium of dielectric constant five attract when two charges placed at a distance 20 centimeter in a medium of dielectric constant 5 attract each other by force of 20 Newton. Find the force when same charges are placed in air at a distance of 30 centimeter. Okay. Yes. Anyone got the answer?
400 by 9, sir.
So your answer script, copy yourself.
Whose?
Your copy.
I have done in rough, sir.
480.
Huh?
80 by 9 I'm getting, sir.
I'm getting 400 by 9. Let me
I'm
see.
getting 80 by 9. Let me see.
Shreyas,
Any
where
other?
are you? Shreyas,
Decimal I am getting, sir.
how much?
How much?
Sir,
44.444.
That is 400 by 9.
That
400.
only.
That is correct only. I'm wrong. Wait.
Here product of Q1, Q2 will take out and use in second equation.
That only I was, for that only I was saying the you show your copy.
In rough, yeah, I have done.
Same here.
So we have not to find the product first and then we will use that one. Simply we will find them by the ratio method. So when they are placed in medium, what will be 1 by 4 pi epsilon naught epsilon r q1 q2 over r square. Okay. Now what are the things which changes? Charges are same. This distance is changing. So we take here r1. This f naught you are asked. 1 by 4 pi epsilon naught q1 q2 over r2 square. Okay. So this f naught you are asked, f m is given. So what will come? This by this. So 1 by 4 pi epsilon naught q1 q2 cancel. So what is left? Epsilon r, yes, r1 square over r2 square or r1 over r2 whole square. Fm you are given how much? 20 Newton. Epsilon r is given 5. R1 we have taken the medium, that is how much? 20 centimeter. Both are in centimeters, so no need to change also. So how much it will come? 400 by 9 Newton. So this way we prefer ratio method. When one is given and other you are asked, prefer this one method. No need to find this one, do calculation here also. Again you will do calculation here, no need. Many things will be cancelled and then we will get the result in one step only. Okay, now superimposition of the forces. That is how you find the resultant when more than two charges are present. When you are asked find the force experienced by a particular charge when more than two charges are present, that we call superposition principle. Same as we have done in case of class 11 also, so many superimposition principle we have done. So same thing here also. Superimposition or superposition. So when more than two charges are present, just simple example, suppose three charges are there. Suppose this is A, B and this is C. This is suppose plus Q1, this is minus Q2, this is plus Q3. Now you are asked, find the force experienced by C. or charge Q2. Then what will you do? So we will find what is the force experienced by this charge due to this charge. What is force experienced by this charge due to this charge? And then we will find the resultant, because force is a vector quantity. So what is the force experienced by this due to this? How will you find? So this F23 will be our 1 by 4 pi epsilon, suppose K, Q2 Q3 over R23 square and unit vector. So what will come here? If we are using this vector symbol, what will come? So this is suppose K. If this is suppose here minus 2 Coulomb, this is 3 Coulomb, this is 5 Coulomb. What will come here? So K means whatever value will come. Q1, Q2, that is, we will say it is minus 2 into 5 by whatever the distance may be given. Okay, suppose this is 3 meter, this is 2 meter, this is 4 meter, maybe whatever it is. R23, that is 9. Now what is the direction? 3, 2. Yes, this is the direction. But here is coming negative sign. What does it mean? Opposite of 3, 2. If you are not giving here minus sign, that means what? Direction is minus 3, 2. What is the direction now? This one. By using vector having negative charge, this is positive charge, so this will be attracted. We are interested only in this particular charge. We are not thinking about what force is experienced by this or this, because we are asked only force experienced by Q2. So what is the force experienced by Q2 due to Q3? Now similarly, what is the force experienced by Q2 due to Q1? What is the direction? Magnitude will find Q1, Q2 over this distance. So F21 K 2 into 3 or minus 2 into 3 by distance is 4. If you are removing minus from here, then what will be? R12 with negative sign. R12 is this, minus of that is this direction. So this one is experiencing force of attraction. So we will find these two forces, and the force experienced by this two general will be what? F21 plus F23. Sorry. So according to this superimposition principle, what will be? When you are asked to find the force experienced by a particular charge, we will consider the forces experienced by that particular charge due to other charges. And then the net force will be the resultant of all the forces. So that is our general formula. So force experienced by this, suppose 3, or force experienced by this fifth, maybe force experienced by 5-1, force experienced by fifth charge due to second, force experienced by fifth charge due to third, force experienced by fifth charge due to fourth, fifth charge due to 5, 0 only. So no force will be there. So this way we will find the resultant of all the forces. So we'll leave up to here. You solve the numericals. Yes.
Thank you, sir.
Thank you, sir.
Thank you.
Thank you, sir.